this variable, the first variable, the meaning. So MN, I want to use it to, refer to, M refers to menu bar. Remember, the last time I showed you the menu bar. The menu bar, we put table names, 5 table names there, all right? But when you choose, you need to select one of the 5 tables. Which table to choose? You need a table number, right? Yeah. So this menu, M menu N number, okay? Yeah, refers to the meaning, MN, okay? So the table number, the first table, 0, table index, okay? Yeah. When this number equals 0, that's the first table. When this number equals 1, the second table, and so on, okay? Table 5, this number equals 4, all right? Yeah. In this way, we can control which table we want to work on, okay? So this is one variable we use. Then, let me explain this line. This line also important, okay? All right. This line, INTVAL, this function, from the name you can see, we want to convert the number from string to integer. INTVAL value, integer value, yeah. The input is a string. Convert from string to integer. Yeah. All right, so if you can hear, yeah, from string to integer. Okay, yeah. So this whole function, this function, the input in the string format to int. All right, yeah. But in the conversion, let's look at the inside part. Inside part, we use another function called filter underscore input. Yeah, the name you see, we are doing filtering. Yeah. So input, that means we retrieve the data from some input field. Input. Okay. But after you retrieve the data, in order to avoid, some potential hacking risk, yeah, some, hackers use the embedded code, try to steal your data from your database, yeah, things like that. Okay, so PHP has a function filtering the data, input data, try to protect, yeah, eliminate those harmful code. Yeah. So you understand the meaning. So we do the filtering. Then 2 parameters here. The first parameter, you look at this, input underscore get. It's a constant. Yeah. So capital, it's an internal constant. Internal constant. When you use this internal constant, what's the meaning of that? So here the meaning is retrieve the input data from the get. So here there is a get scope. So what's that? All right. Yeah. So here, yeah. So here some background knowledge you need to understand. Yeah. Related to HTTP protocol. Yeah. So people use HTTP a lot, right? So what's that HTTP? That protocol. Hypertext, some protocol, right? Yeah. So when we do data communication between client and server, we need to use this HTTP protocol for the communication rules. You need to follow communication rules. So, but when you send the data, you heard send data, there are two main methods, get method and the post method. Get, post. Actually, there are total 6 methods, but these 2 are used most of the time. Yeah. The remaining 4 rarely used. So we don't need to touch those rarely used 4 methods. Yeah. So we only focus on these 2 main methods, get method and the post method. When you send data through these 2 methods, the rules are different. Okay? The HTTP protocol, the rules in the protocol are different. They follow different rules. Okay? Yeah. Here at this point, because when I talk about get method and post method, it takes quite some time. So today I do not elaborate. Okay? Later, I will, because I want to split our code explanation in several classes. Yeah, so the next time I'll try to find a chance to talk about get method, post method. So here, 2 different methods to send data. Yeah. All right. So then the data is stored in different scopes. Okay? Different locations. When you use the get method, so the data stored in one particular location. When you send the data through post way, the data is stored in a different location. Okay? Yeah, so that location I will describe later. Yeah. Today I try to do things simple, in a simple way. Yeah. So I try to add more and more knowledge later. Okay? Yeah. All right. So now we send the data using the get method. Then, when you retrieve data, you have to retrieve from the, get scope. Okay? Yeah. From there. Otherwise, you cannot get the data. All right. So here, yeah, we know the data should be in that get scope. All right? Yeah. So here, we use the get. Then, the parameter name. When you send the data, how to retrieve the data? When you send the data, you should provide a name for the parameter. Okay? Yeah. So this second parameter, this is the name of the parameter. All right? Yeah. So we retrieve the data under the name MN, name. Okay? Yeah. Here, I haven't shown you how to send the data. Later, I will show you. Okay? So here, we just receive the data. Yeah. But we need to send it first, right? Yeah. We need to send the data first. Yeah. So we will get there quickly. Yeah. All right. Now, you retrieve the data first. Yeah. Why the first line we do this? Because we want to display the data of one of the 5 tables, right? One of the 5 tables. Which of the 5 tables you want to select? You don't know. So the first thing, we retrieve the data to tell us which of the 5 tables we want to use to do the query. Yeah? All right. So this is the first line. After that, then we need to do database connection. These rows, the standard way we do database connection. Okay? You can see some standard information. You need to pass certain function to do the connection. DB host, the host name, yeah, local host. Yeah. So our MySQL running on our local machine, so we can access through local host. username, password, yeah. So the default user account, root account, the top level root account, it's called root. Yeah. The default password, if you do not change, after you install MySQL on your computer, yeah, it's empty, nothing. Yeah, yeah, password, nothing. Okay, yeah. That the database name. Yeah. After we install our database, so there is a database name. Okay, all right. So with these 4 parameters, you can make the connection. Connection use the MySQL I version. There is I. Without I, it's the old version. Okay, the old version slowly degenerated, so we should not use old version anymore. So the I version is the newer version. Okay, all right. MySQL I underscore connect. We call this function to make a connection. The function you pass the 4 parameters. Okay, yeah. Then after it is connected, yeah, this function, you make that connection. After it is connected, you get a connection object, $CONN. Yeah, this variable contains the connection object. Yeah, we know PHP is also an object-oriented programming language. Yeah, so we use objects to handle the data. So this is the connection object. When you do the query, we need to use this connection object. Okay? Yeah. All right. Then test if the connection is successful. This if statement, we do the testing. Yeah. Sometimes it may not be successful. Yeah. So do the testing. Yeah. Not connection object, because if it fails, that means the object is empty. Yeah. Yeah. If the connection fails due to any reason, okay, whatever reason, then this function does not return any data. Okay, so it's empty. Empty in if statement, empty object is the false, right? Yeah, empty means false. Yeah. Non-empty means true. Yeah. Yeah. When you check the condition for the if statement, empty means false. Non-empty means true. Yeah. Not, so if it's empty, not empty, that's true, right? So if it fails means empty. The whole object is empty. Empty, but it's false, but you negate it. Not false, it's true. So if it fails, you print out the error message. Okay? Error message. If it's true, then the condition is false, right? If your connection object is non-empty, contains something, okay, then not true, it's false. False, you get out of the if statement. So you keep doing the remaining statements. All right, so we pass the connection part, database connection part. All right. Then, to do the data processing, yeah, we need to use PHP array. Yeah. PHP array. So here, the simple way to use PHP array. Yeah. First, we need to declare our variable for the array. So this TBLARR. So this is the variable array name. Yeah. Array name, we use this array constructor. See, array constructor. So we get array object. Array is treated as an object. Okay, array object. All right. Then you need to do initialization. Initialize your array elements. And here, this is a convenient way in PHP to do the initialization. So you do not provide specific index number, although you can. Okay, if you put a specific index number 0, 1, 2, 3, it's fine. Yeah, but there is a convenient way. You do not specify it, then it uses the default value. Okay, the first default value is 0, second default value is 1, and so on. Okay, yeah, keep adding up, incremental. Yeah. All right. So here we store 5 names for our 5 tables. Yeah. So this array we store the table names, 5 table names. Yeah. Okay. Yeah. That's simple. Then, but the current table, we need another variable to tell us what is the name of the current table. Yeah. So this variable, $table underscore the current table. How to get current table? Yeah. So because here we assume there is a selected number we retrieve from the input. Okay? Retrieve from the input, we know which table we want to use. Yeah. So we know the index of the selected table. So we use this $TBLARR, that we pass the index number to this array. So we retrieve the table name for the selected table. Then we can do the query. Okay? Yeah. Next, we can do the query. Yeah. Now we prepare. Yeah. Now we do the query preparation. Yeah. All right. So here, so this is preparation part. So it is a query, but this query is a little special. Yeah. So this query, because we need to get some information. Yeah. So we need to get info of the current table. Yeah. Yeah. Because here we do not want to use the hard-coded way. Yeah. So here you can see we want to get a column information. So this information is the column information. Column information, although we can find it in our database design, but you don't want to use the hard-coded way, right? Yeah. Yeah. So here we want to, using some adaptive way. Yeah. Because when you change the tables, you also need to change the columns, right? Yeah. So here we retrieve the column names for the given table. Yeah. Because the table name is known. So we run a query. So what's the query? Show columns from table name. That's the SQL statement. Okay? Yeah. So there is a SQL statement. You can do it. Show columns from table name. Yeah. So this query will return a list of column names. Okay? All right. So then we run the query. When we run the query, in the query there are 2 parameters. The first parameter is the connection object. You need to pass the connection object to it. Okay? Yeah. Then the second parameter, that's the query. Yeah. So here, why we pass the connection object as the first parameter? Yeah. So here, there is some good reason for it. Yeah. Old version, I mentioned this I version is the newer version. Older version, there is no I. For the older version, MySQL underscore query, we do not pass connection object. Okay? We pass the query string directly. Yeah. So if we do not pass connection object, then there is a default connection object. Default connection object has no name. Yeah. But you do not need to refer to it. Yeah. So every time when you need to do the query, you take the default connection object. Yeah, that's the older version. Why the newer version added this connection object as the first parameter? Because if you use the connection object as the first parameter, in your program, you can access multiple databases, right? Because your connection object 1, that's your first database. Connect to connection object 2, you connect to second database. If you have several databases, you can access in the same program. But if you use the old version, you only have one connection object. Yeah, because default, default only one. Okay? Yeah. If you want to access the second, destroy the first one. Then create the second one, access. After that, you need to destroy the second one, then connect the third one. Right? Because you only have one place to handle your connection object. And here, this version, you can use multiple connection object with, here, there, anywhere you want to use. Yeah. So very convenient. All right. So that's the, so this is the, first screen of the code. Yeah. Yeah, let me look at, I need to control the time. Yeah. Because I do not want to use too much time. Yeah. All right. Yeah. So, we already use half an hour. Yeah. Let me switch to the part D. Yeah. Yeah. So the first screen. Yeah. So give you some basic knowledge. Yeah. Next time we complete the remaining part. Remaining part, we will do our main query. After main query, we display data. So that's all we need to do. Okay? Yeah. The second half of this program. Yeah. So let me go to the part D. Yeah. Complex. Oh, no. Yeah. I want to, here. Yeah. Complex queries. All right. Yeah. And we will practice this part, complex queries, in our homework assignment number 3. Yeah. Yeah. All right. D.1, correlated nested queries. Yeah. The structure of the complex query, correlated nested queries. Yeah. So let me describe the structure first. All right. So what is the structure? Yeah. Definition of this type of query. Whenever a condition, just a minute. I need to set up a timer. Yeah, I forgot to set up a timer. Yeah. So I may not. Yeah, because I need to control the time. Yeah. So timer. Let me see. Remaining 40 minutes, right? Yeah, remaining 40 minutes. Okay. Yeah. All right. Remaining time. All right. Whenever a condition in the where clause, here, we look at the where clause part of a nested query. Yeah, so here, nested query. So when we talk about nested query, you have inner query and outer query. Inner query and outer query. That's the nested. Like nested for loops. Inner for loop, outer for loop, right? It's the structure like that. Yeah. Query will also have that kind of structure. Yeah. Outer query, outer query. Yeah. So later when we see example, you can see outer query, inner query. Yeah. Yeah. References some attribute of a relation declared in the outer query. Outer query, select from where clause, that's the outer query. Okay? Starting from select from where. That's the whole thing, that's outer query. But inside your where clause, you have another inner query. You have another level of select from where, inner. Yeah. So that's the nested. All right. The two queries are said to be correlated. Now, then your inner query needs to refer to the outer query, some field, some attribute. Yeah. When you have this kind of property, then you have a nested correlated query. Yeah. Yeah. But your inner query may not refer to the outer query. That's possible. But if you do not, in your inner query, you do not refer anything, any attribute, any field of the outer query, that's not correlated. Okay? If it's not correlated, then it's simpler. Yeah. So it's a nested query, but not correlated. Yeah. Then it's much simpler. No relationship. Yeah. But relatively the hard structure, that's the correlated. Yeah. So you need to understand the whole structure. Yeah. Yeah. So you need to, because when you need to work on your query, complex query, so you need to understand the relationship. Okay? Yeah. All right. That's the structure description. Then understand correlated queries. This time. Yeah. So we can understand a correlated query better by considering that the nested query is evaluated once for each tuple or combination of tuples in the outer query. Yeah. So here, yeah. So this is the basic way, so we understand. Yeah. But yeah. So here, so it is a little abstract here. Yeah. All right. So outer query. Suppose this is outer query. Outer query. Outer query, we process table row by row, right? Yeah. So outer query, we process query row by row. Yeah. Let me use capital R1, R2. Yeah. Rn. Okay. All right. Then, row by row, each iteration, we work on one of the rows, right? Yeah. So the outer query, we need to select one of the tuples in outer query, all right? So then you go inner query, okay? So when this is selected, you fix it. Fix it. Okay? Then you get into the inner query. Inner query, you have another table, right? Yeah. Another table, this time you're going through all the rows. Let's use little R1, R2, RK. Okay, all right. So here, this understanding description tells us after we fix the outer query, R something, capital R something, then we get to the inner query, we need to go through all the tuples, yeah, evaluated once for each tuple. Yeah. Yeah. So the nested query is evaluated. So this is the nested query, okay? Nested query, that's the inner query. Yeah. Inner query, you need to check the condition, right? So here, evaluation means you check the condition. When you check condition, you use the fixed tuple outside. Then, for R1, you evaluate once. R2, evaluate once. R3, yeah, each one you evaluate once, and you only select those that return true values. Yeah. Okay? Only select those that return true values. Yeah. So this is the, typical way to understand. Yeah, similar to the for loop. Outer for loop, you select one iteration, right? Yeah. Then you fix it. You take that iteration, then you get into the inner for loop, so you going through all the iterations of the inner for loop. Same way, yeah, for the nested queries. Yeah. All right, yeah. So later, we will use this way to understand our complex queries. Yeah. All right. Next, yeah, any and some in combined operators. Yeah. So here there are several ways you can use any sum. Yeah. When I did a grading, I saw some students, not many, use these operators already. Yeah. Here just, although actually most of the time, most people do not use. Yeah. Most people just use the straightforward way. Yeah. But here to give you these special operators, you can understand. When you see it, you can understand the meaning. Equal any. So this is a combined operator. Combine, that's more than one operator. Okay? You combine. Yeah. You combine two operators. So combined operator. Any is one of the combined operators, sum. Yeah. Equal any. Okay? The first operator is equal sign, second is any. And or equals sum. Okay? The meaning, just from the, you can guess the meaning easily. Equal any of the tuples. Yeah. Yeah? So equal any, then the parenthesis, it is an inner query. Okay? Inner. So here, the current tuple equals any of the tuples in the inner query. Yeah. So you can see. Yeah. And yeah, equivalent to in operator. So here, yeah, I talked about in operator before. Yeah. So here, we need to start using this in operator a lot. Yeah. Because most of the time people use in operator. That's easy. It's not a combined, a single operator. Okay? In means combined operator. Equal any means in. Okay? Equal sum also means in. Okay? Yeah. So most of the time people just use in operator. Yeah. Yeah. But you can understand if some people happen to use rarely use the combined operator. So you know the meaning. Yeah. All right. Yeah. Operators other than equal sign can be combined with any, some and all. Yeah. Less than. Yeah. So all these signs, operators can be combined with any sum. Yeah. So you just use the natural meaning to understand. Greater than any. So you know the meaning, right? This tuple, yeah. So this value, usually there is a numerical value, or a value, not necessarily numerical value, because we can compare string. Okay, yeah. There is a value greater than any of the values in the inner query, the tuples of the inner queries. Yeah, yeah. You just use the natural understanding. Yeah, you can do that. All right. Yeah. All right. So here, give you an example. Yeah. Salary. Yeah. So first, this is a nested, correlated, nested. Outer query. So this select from where. This is the outer query. Select from employee. Yeah. Salary. Yeah. This employee, its salary is greater than all of them. Okay, greater than all of them. Okay, greater than all of them. Inner query. Yeah. Inner query, the salary, employee. So from department 5. Yeah. So you retrieve all the salary numbers for the employees in department 5. Okay. Yeah. So this is a simple example. Yeah, simple, nested, correlated. Oh, is this correlated? This is not correlated, right? Yeah. This is nested but not correlated because in our inner query we do not use any field from the outer query, right? Yeah. So this one, yeah, we list the salary for employees in department 5. For any employee, we do the same thing. We do the same thing. No change. Yeah. So this is not correlated query, although nested. Yeah. Yeah. All right, but here, just show you this greater than all operator. Yeah. All right. D.2, aggregate functions. Yeah. So we in our homework assignment number 3, we will do a lot of queries using aggregate functions. Yeah. Yeah. It's straightforward. Yeah. It's not hard, but the queries could be very hard. Yeah. The queries related to aggregate functions could be very hard. Yeah. All right. So let's look at the aggregate functions. Yeah. All right. Summarize information from multiple tuples into a single tuple summary. Yeah. When you apply a function, you get a single tuple value, right? Yeah. But your function you apply on a table on multiple tuples. Yeah. All right. Example. Yeah. Count function. Yeah. You count the number of rows in the table, right? So you get one number, one counting number. Yeah. Count function. Sum function. Yeah. You take summation. You add up all the values for a particular field of the table, and the function returns one value. Yeah. Max function, min function, and average function. Yeah. So the commonly used aggregate functions. Yeah. Okay. Yeah. All right. Yeah. Grouping. Yeah. Yeah. But when we use the aggregate functions, although you can apply these aggregate functions directly on one table, yeah, but that is the simplest usage. Yeah. Yeah. When you apply these aggregate functions on one whole table, okay, yeah, that's the simplest usage. Yeah. There is a second usage, a little harder. Yeah. Second usage is you do not apply your aggregate function on the whole table at the same time. You do grouping first. Yeah. So here I talk about grouping concept. Yeah. You group, so you start from the original table. Yeah. So original table, there is one table, right? Yeah. So here you want to apply aggregate functions on this table. Yeah. All right. But before you apply aggregate functions, you want to do the grouping. Okay? You want to group the rows in the original table first. You want to define subgroups. Okay, all right? Subgroup 1, subgroup 2, subgroup 3, and so on. Okay? Yeah. Yeah. Multiple subgroup. All right? Yeah. After you define subgroups, how to define, we will talk about that later. Okay? Yeah, there is a way to define subgroups. After that, then when you apply aggregate functions, you apply each aggregate function on each subgroup. Okay? Subgroup 1, apply once. Subgroup 2, second time. Another time, all right? And so on. Yeah. That's the many times we need to use aggregate functions in this way. Yeah, this way. Okay, all right. Yeah, so we need to understand the second way a little more. Yeah. Grouping. Yeah. Grouping is used to create subgroups of tuples before summarization. Yeah. You need to define subgroups. How to define? Yeah, so there is a simple way to define. Group by, okay? There is a group by clause we can use to define our subgroups. Group by clause. Yeah. Yeah. All right. Use group by clause. Yeah. Yeah. Very simple way we can define. Okay? Yeah. All right. So later we will see some simple example so you can see how to define. Example, a correlated nested query with an aggregate function. Yeah. All right. Question. Retrieve the names of all employees who have 2 or more dependents. 2 or more. Okay? Yeah. Yeah. All right. So they have a condition. Yeah. Yeah. So those employees, yeah, with 2 or more dependents, yeah, you need to count, right? Yeah. Yeah. So here, let's do analysis. What do we need to do in this query? Yeah. First, our outer query, we need to go through our employee table. That's the outer query. Okay? Select from the employee table. Yeah. Then, for each employee, we need to get into the inner query to look at the dependents of this employee. Okay? For each employee, you fix the employee, all right? You fix the employee. Then, you get into the inner query, and you want to go through the dependent table for the current employee, all right? But when you go to the dependent table, you need to count the number of dependents, right? Yeah. You need to count the number of dependents, yeah, all right? Yeah. But when you apply count function, aggregate function, on the dependent table, you need to define subgroups, right? Subgroups, okay? The subgroups based on the employee SSM. Yeah. Each employee, you use its SSN to define subgroup. Yeah. One employee may have multiple dependents. Okay? So you put all the dependents of this particular employee in one subgroup. How about that? Okay? For a different employee, you have a different subgroup. Okay? So you have many subgroups. Then you apply the count function on all these subgroups. How about that? Okay? Yeah. So that's the understanding, yeah, before we write our query. So the older version, yeah. So older version, that means we do not use aggregate function, although we can do it, but not very neat. Yeah. Yeah. So the new version, we apply the aggregate function, then very convenient. Yeah. So the older version, you can see, we use this unique function, not unique. Yeah. 2 or more, then not unique, right? Yeah. So here, you have a nested query. Your outer query employee, all right? So you fix one employee from the outer query. Then you get to the inner query from dependent table where e.ssm. So, yeah, so you fix the SSM. Yeah. When you go from outer query to inner query, this SSM, it is fixed. Okay? This SSM you can change. This ESSM, you go through all the ESM in the dependent table. Okay? All right. Yeah. So then you apply unique function. Okay? Yeah. So you do the query. The query should return certain number of rows, right? Yeah. So yeah. If it's one row, that is unique, right? Yeah. It's unique. Yeah. All right. So if it's more than one row, it's not unique. Yeah. So not unique. So you get those employees not unique. Yeah. So that's the old way. Yeah. Because this old way, you do not use the aggregate function. Yeah. Yeah. So this old way is not as good as the new way with aggregate function, because if you change 3 or more, that is hard. 3 or more, you cannot separate, right? Use the older way. Yeah. So you should, if you use the count function, you can separate easily. Yeah. Use the count function, outer query, but the inner query, you apply the count function. Count function, yeah, all right. So yeah, so here we do not need to define subgroups, yeah, because here, when you fix SSM, all right, when you fix SSN, you match all the ESN to this fixed SSN. There is only one group, right? Yeah. For other ESN not equal to, we throw away. So we only have one group. Why you need to define subgroups? Okay. Yeah. For the special case, when you only have one group, you do not need to define any subgroup. Yeah. So here we do not define subgroups. Yeah. So all the ESN that equal to SSN, there are a certain number of rows. Now you apply count function on those rows. So it returns the number of rows. That number, when it is greater or equal to 2, the condition is satisfied. So you select that employee. Yeah. Yeah. Pretty straightforward. Yeah. Yeah. The newer version better than old version, because if you change to 3 or more, you just change greater or equal to 3. Very easy. Yeah. For the older version, extremely hard. Yeah. Unique cannot separate 2 and 3. It cannot separate. Yeah. Yeah. So, yeah. So that's this example. All right. Then max and min functions, maximum and minimum, functions. Yeah. All right. Can be applied to a multi-set of numeric values. There are 2 cases: numeric value and a non-numeric value. Yeah. Numeric value, that very easy to understand. The maximum numeric value, or minimum numeric value. Yeah. But for non-numeric value, we have order definition, right? So based on the order definition, what is the maximum value? What is minimum value? Okay? String, we can apply max function. String, the one with the maximum string value, we can find a value. Okay? Yeah. So can also be used with attributes that have non-numeric domains if the domain values have total order. Yeah. So here the concept total order among one another. Yeah. Total order means all the elements you can do comparison. All the elements with total order you can compare. Any 2 of them you can compare. That's the total order. Yeah. So you don't want you just pick arbitrary two elements, then you can do the comparison. You can have a valid comparison. That's the total order. Okay. But that's probably your current understanding of the order, right? Yeah. So most people understand the order, total order. Yeah. But there is another concept called a partial order. Partial order. Yeah. So you may not have any idea on partial order concept. Although for this class we do not need to worry about the partial order, but there is a partial order concept. Yeah. So here I just mention a little bit. Yeah. Yeah, because when you talk about total order, if I do not talk about partial order, then you may feel why we say total order, right? Yeah. 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 So the reason is the partial order. Yeah. You can consider the cases. There are multiple elements. We can define certain order, right? The order, people can define the meaning of order. Yeah. But when you define order, then you have partial order means sometimes you can do valid comparison. Sometimes you cannot do valid comparison. Not all the time. Okay? Sometimes valid comparison. Sometimes. If you do comparison between 2 elements, no result. All right? Yeah. Because any comparison is invalid. Yeah. How to see that? So here, let me give you one abstract example. Yeah, because in the real world, it is very rare to have the partial order case. Yeah. Although it exists, yeah, but the percentage is very low. Yeah. So that's why most people don't know this partial order thing. Yeah. But there is some some special situation. Yeah. Here, let me define. Let me do some order definition. Okay? Yeah. People define order. Okay? All right. Let me use a simple example in graph theory. Yeah. Graph theory. Okay? Yeah. Yeah. Graph. Yeah. Graph theory in computer algorithms. There is a topic called graph theory. All right? Yeah. So in graph theory, let me draw a graph. One special graph. Okay? All right. Each graph is formed by vertices and edges. Okay? Now, vertex A, yeah, vertex B, and this is the edge between A and B. Yeah, and it's a directed edge. Okay? Yeah, there is a direction. Okay? One-way street, you can only go from A to B, but you cannot go from B to A. Okay? So it's the directed graph. All right. Then from B to another vertex, we call it D. Okay? You have to follow that direction. Okay? Not the opposite direction. Okay. All right. Then similarly, I can define another edge from A to C. C vertex. And another vertex from C to D. Yeah. So when I have a valid graph, yeah, directed graph, yeah, this is a valid graph. Okay. All right. Then I can define order between these elements, 4 elements, A, B, C, D. I define an order. Okay. All right. Yeah. All right. A greater than B means there is an edge from A to B. Yeah, that's the way we. That's the way we define an order. Right? Yeah. And we can verify it's a valid definition of the order. Why? Because it follows the transitivity property. Yeah. How to see an order definition is valid? If your definition of order follows the transitivity property. Yeah. All right. Yeah. Transitivity. Okay. All right. So. Yeah, so here transitivity, yeah, so if, not edge, if, because edge, then you may not have the transitive part. If there is a path from A to B, path from A to B. You know, path is formed by edges, right? From A to D, you have a path. Then A to B, then from B to D, this is a path, okay? Yeah, a path is formed by multiple edges. So you can get there, okay? Yeah. So you follow these edges, you can get to the destination. Yeah. The starting point, end point, there is a path. Yeah. So we define, yeah, A greater than B, then there is a path from A to B. Yeah. All right. Then this follows the transitivity property. This definition follows the transitivity property. Yeah, so that's a valid definition. Okay? Yeah, all right. Then, based on this definition, is there an order between B and C? There is no path between B and C, right? Yeah. That means when we select, yeah, because if there is a total order, you select arbitrary 2 elements, you can find an order. But here we select arbitrary 2 elements, B and C, there is no order between them because no path from B to C and no path from C to B. Yeah. All right? Then, so we call this order, it's a partial order. It's not a total order. Yeah. Here, I'll give a simple example to explain the concept. Yeah. All right. Yeah. But in our class, so we will not have the situation we need to deal with the partial order. Yeah. Yeah. But the concept, you know this concept. Yeah. All right. So here I give you the total order, the definition. Every two elements can be compared in one of the three cases: equal, less than, greater than. Yeah. Yeah. But this example, partial order example, you can see we cannot do comparison, right? Yeah. When we compare B and C, yeah, these three sides, none of the three cases works, right? Yeah. Equal doesn't work. Less than doesn't work. Greater than doesn't work. Yeah. So that's the problem. Yeah. All right? Yeah. So now you can see for the max and min function, yeah, the only requirement we need here, yeah, we need a total order in the domain. Okay? Yeah. In the domain of the field. Then you can apply these two functions. Yeah. All right. Yeah. Yeah. Okay. Yeah. All right. Yeah. Yeah. Partial order. Okay. Yeah. Not necessary. Yeah. So I here I give you the formal description. Yeah. All right. Deep on 3. Now partition for grouping. Now we need to see some examples on the concept, grouping concept, how to define subgroups. Yeah. Very simple, very natural, yeah. But I need to describe the special way. Yeah. All right. Partition concept for grouping. Yeah. All right. Partition a relation, yeah? Because you need to do one special operation on a table. What's that operation? Partition operation. Yeah. So here there is a partition concept. Yeah. So let me explain this partition concept before we can understand the grouping. Yeah. This concept we borrowed from math set theory. In math set theory, there is a special operation, partition of a set. Yeah. We can divide a given set into subsets, multiple subsets, yeah, in certain way. Yeah. Yeah. So we need to follow certain conditions to get a valid partition. Yeah. So this partition, you need to follow certain conditions to get a valid partition. So what kind of conditions do you need? Yeah, so here, yeah, we can look at in math, these conditions we need to follow. Yeah. All right. So here, let me write in math. So suppose there is original set. S is the original set. Okay. Now we want to divide this S set into subsets, S1 union S2 union ... union Sn. Okay? Yeah? Split the given set into multiple subsets following certain conditions. First, okay? Following certain conditions. First, the subsets, all the subsets can cover the whole set. Yeah, that's the first condition. Condition number 1, whole coverage. Yeah, you cannot miss. Yeah, so the subsets, if you take the union, so what do you mean covering? If you take the union of the subsets, you get the whole set. Yeah. So this property address, this property address this condition, okay? The whole coverage condition. Yeah. Okay? Yeah. The whole coverage means this. Union of all the subsets equals the original set. Yeah, union subset equals the whole set. Then second condition, non-overlapping condition. Yeah. So your subsets, you select any two subsets. If you take intersection, it must be empty set. This is the empty set. Empty set. That's what we call the non-overlapping condition. Yeah. There is no overlapping between any two subsets. That's the meaning. Yeah. Non-overlapping condition. Okay? Yeah. Here. The second condition. Yeah. All right. Then third condition, non-empty. So each subset cannot be empty set. Yeah. Si or Sj cannot equal to the empty set. Yeah. So this is empty set. Empty set. Okay? Yeah? Non-empty. Yeah. Otherwise, you remove it, right? If any S subset is empty, you don't need to put it in the partition. Okay? You take it away to simplify your partition. Yeah. So that's the concept from math. Yeah. These three properties. When you do a partition, when you do split division on a set, if you have these three properties, then you get a valid partition. Okay? Yeah. So here we borrow this concept from math and to our grouping process. Yeah. So our grouping, the way we define subgroups should follow these three properties to form a partition of a set or multi-set. Yeah. All right. Yeah. Yeah. So this is the third property. Okay. All right. Groups and the grouping attributes. Yeah. Partition a relation into non-overlapping groups of tuples. Yeah. All right. How to partition a relation? Yeah. Yeah. Very simple. Group by clause, using the group by clause. Each group will consist of the tuples that have the same values of some attributes. So we call the grouping attributes. So we use the attribute values to define subgroups. Simple way. So attribute values we put in the group by clause to define subgroups. That's simple. Okay? Yeah. So here, sometimes we use one attribute. Sometimes we use multiple attributes. Okay? Yeah. So, yeah, two cases. One attribute very easy, and multiple attributes, yeah, a little harder, but still, you can define subgroups. Yeah. All right. I hope I can give you one example. Yeah. 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 All right. Yeah. Let me do this simple example. Okay. All right. So we get department number, and we count the number of employees in this department. Then we calculate the average salary in this department. Using the employee table, how do we define the subgroups? After group by clause, we use department number, its value, department number 1, number 2, number 3. There are 6 values, right? 1, 2, 3, 4, 5, 6. So we define 6 subgroups. Yeah. So all the employees that belong to department 1 in one subgroup. For that, we apply these two aggregate functions. Yeah, pretty straightforward, the understanding. Yeah. So this is the simple way to define. Use one attribute, define subgroups. Yeah. Next time, I will give you the more than 2 attributes to define subgroups. Yeah. Sometimes we need that. Yeah. More than 2 attributes. Yeah. Right. Yeah. So let's stop right here. Yeah. I'm doing the revising my project description. Yeah, so tonight I try to complete. So sometime tomorrow I will post our project description for project number 2. Yeah, yeah. So you can check the canvas sometime tomorrow. Okay. Yeah. All right.